Hello and welcome to PB Edu channel. So here we solve all your queries related to your school problems. The videos till now are all in English. If you want any solution in Hindi, you can tell that in comment section below. So today we have a question of class 11th chemistry from chapter 6 thermodynamics. Here we have to select the correct relation for isothermal reversible expansion of an ideal gas. So first we will understand what is isothermal. Isothermal means when the temperature is constant, a process in which temperature is constant. Temperature is constant means del T will be 0. We can say that final temperature is T2 and initial temperature is T1. And temperature is constant implies that T2 is equal to T1. When T2 is equal to T1, then del T will be equal to 0. So this is the condition for isothermal process. And the second is reversible expansion. So when we are talking about reversible expansion, it means we can reverse the process. If we are expanding, expansion means we are giving more space. If this is like this, there is gas inside it and the particles are all near to each other. There is gas inside this pump and now we will pull the lever up. So we are expanding. We are helping the gas to expand. So there would be more space. So gas particles would be away from each other. So we can say that in this case, entropy, because entropy depends upon randomness. Here, gas particles will have less space to move. So there would be less randomness, S1. And in this case, the entropy would be greater because now the gas particles have more space to move. So we can say that S2 is greater than S1. And if we talk about change in entropy, it would be also final minus initial. So S2 is greater. S2 is greater. We are subtracting a smaller value from a greater value. It means answer would be positive. Therefore, for this process, isothermal reversible expansion, it is in it the change in entropy is positive. So we had to select correct relation, but the first relation given is incorrect. Del S is equal to 0 is given, but we know that for the given process, del should be positive. So therefore, first option is incorrect. Next is del G is equal to minus C delta S. So if we talk about relation of del G with delta S, so it is del G is equal to del H minus T delta S. This is change in enthalpy, this is Gibbs free energy, this is temperature, and this is change in entropy. So we know what is change in entropy, but we don't have to put the value. Here we need del G is equal to minus T delta S. So minus T delta S would only be possible when del H is 0. So we will talk about del H, and the next option is also here del U. So we will talk about the del U and del H relation with temperature, because here del T is also 0. There is no change in temperature. So the formulas are NCP del T and NCV del T. So we can see in both the case, in del H and del U, change in enthalpy and change in internal energy, there is del T. And we know that del T is equal to 0 for isothermal reversible expansion. So if we put the value here, 0 in both the cases, so we would get that del H is also equal to 0. What it implies? Del H is equal to 0 for the given process, and del U is also 0. But the given statements are del H is not equal to 0, but we know that it is equal to 0, del U is also 0. So the given options are incorrect. The correct relation for the given process is this. So we had to tell if del G would be equal to minus T delta S. So now we know that del H is equal to 0. We would put it here, 0 minus T delta S is equal to minus T delta S. So now we have del G is equal to minus T delta S. So this relation is correct. All these relation, we have all the relations here for the given process. So this option is correct. Option second is correct for the given question. The correct relation is given in option B. So if you like this solution and you want some more solutions like this, if you find any problem in your school about the subject, you can ask me in the comment section below. Please subscribe to the channel for more such solutions.